So we're going to talk about chain drive versus gear drive cams. That's a bit of a debate. So there's some opinion that's going to be mixed into this, but there's some undeniable fact that's going to be brought in. So we'll make sure, as always, we distinguish the fact from the opinion, and then you guys can make your own choice. Probably the best place to start is to talk about crankshafts, because that's really the determining factor about with chain drive versus gear drive and such. But I think first I should give a little bit of history on chain and gear drive. A lot of you guys may know this already, but for those who don't, when the twin cams came out in '99, the cam plate, actually this is a late model cam plate, but it looks almost identical to this. One of the issues that they had, this is an example of an early cam chain. You can see the type of chain that it is. So when you look down on the right side of the engine, where you see what looks like a timer cover coming out, like would have been on the old Evos and stuff, it's actually hiding this cam plate. Okay, and a cam plate actually performs a lot of different jobs, actually. Not only does it support the two camshafts through these holes into the side of the engine case, but it's also an oil distribution block. A lot of people don't look at it that way. You can see there's a bunch of tiny little holes. There's some holes inside here, little holes here, holes on the back. So there's little holes all over this thing, and what it does is it distributes oil throughout the engine. So to give you an example, like the oil pump mounts here, which I'll explain shortly. The oil pump mounts here, and you'll notice all of these veins and patterns, like here and here, and what it's doing is it's distributing oil throughout the engine case. So like, for example, you'd have an oil here where oil comes in. This oil here feeds oil through the crankshaft. It has this channel that comes up. It would feed oil through these ports to lube the cam. The oil comes up inside the cam plate to these small holes here. Those holes go through the engine case to the lifters to keep those pumped up, which is what supplies oil to the top end. And then it continues through to go to a piston oiler, which sprays oil on the on the bottom of the piston to keep it cool. But it also distributes the oil, back out to the oil filter, and then it circles back around, comes back through. The oil here, when it pressurizes, it sends oil up through the flywheel assembly to lube the rods. So a cam plate is a very, very important component. It's responsible for distributing oil. One of the other things that's an interesting deal that is actually a problem they're having on the M8s. They think they've solved it. Well, really, it's a problem on everything, but you'll see this channel here. Inside there's a spring and a plunger assembly, and that is essentially a pressure relief valve. So that controls the pressure through the system. And it's a little needle and seat assembly. So if that needle and seat assembly, on the casting, if the casting's bad, it can bleed off pressure, cause low oil pressure and stuff like that. So this is a pretty important component. So to give you a little bit of history, back in '99 when the twin cam first came out, this assembly, when the chain is mounted here to drive the cam, and then there would be a gear here on the bottom, and it's the flywheel assembly that turns the cams, okay? When that first came out, there was a spring-loaded tensioner here, and it had an extreme amount of spring load to it. And, some lasted 20,000 miles, some lasted as many as 40, but there's a little plastic shoe on that tensioner, and it would wear out over time, okay? And unfortunately, it took several years for HD for it to kind of become a common problem. So there were people with, little fragments of this shoe material that was getting distributed throughout the entire engine. And remember how all these parts are in close proximity to each other, the oil pump and everything else. So that was a pretty big deal. And then of course in 2006 on the dyno model only, they changed this to a hydraulic tensioner. So there was tensioner on the back and one on the front, but it was driven off of hydraulic oil pressure instead of being spring-loaded. So that helped tremendously with the wear on the shoe. It just wasn't as much tension, and because it was based on oil pressure, it only provided the tension when it needed it, and it also it was made out of a better material, so it wore a little better. And that's pretty much that hydraulic tensioning system is the same all the way to current, and it became standard on 2007 models, on all models. And one of the reasons for coming up with a gear drive was to eliminate the cam chain tensioners, and other reasons which I'll get into shortly. Another thing that changed in 2007 when they went to the hydraulic tensioner system was the style of chain. So if we can get a close look here, the type of gear assembly, and then when you go to the later model, it's more of a double roller chain, which was typical on the car engines, V8s, things like that, Chevys, Fords, etc. Had a bit of a chain sprocket there, and it also a little smoother surface here along the edge, which helped out with the tensioners on tensioner wear as well in 2007. Now, an interesting thing, one of the big issues with the chains, the early model, we'll go back to the 2006 and back. One of the real issues was actually the edge of the links. Okay, the edge of these links, when they press these during in manufacturing the individual links, there was a real hard casting mark that was left on the edge all the way around. And believe it or not, the initial wear of the cam chain tensioner from 99 to 06 was due to that heavy casting mark that was there. Some years were better, some years were worse. So that was one of the things that caused the big issue with tensioner wear from 99 to 06. So to make sure everyone understands the importance of not just a cam support plate, remembering it's an oil distribution block, before we get into chain drive versus gear drive, we need to understand the assembly. So I'm going to scroll down here for a second just to see, Matt Smith, here's a trip. Just to make sure everybody understands how the assembly works and how the thing goes together. I think that's an important part. So the only way I know to do this is to bend the camera down. So you won't see my smiling face anymore. So right here, I'm going to show you the end of a flywheel assembly. All right. Interesting thing, these rods, these are supposed to move. Believe it or not, this came out of a running bike. It's pretty crazy, huh? So anyway, what you're looking at here is a flywheel assembly. Let me see if I can move this over. Yeah, here we go. So this is called the sprocket shaft side. This is on the left-hand side of the bike. This is what your compensator and primary chain and all that drives off of on this side. This side is the pinion shaft. Okay, this is the side that is on the right-hand side of the engine, and what is actually inside the cam support plate, or inside the cam chest itself. Now you'll see these two, so I can get this just right, these two surfaces here and here, those are the two surfaces that are supported by the bearings inside the engine case. So what that means is you have this length of shaft here and this length of shaft here that is unsupported. Okay, so that's pretty important. Now, the way this crankshaft is assembled is this half, this flywheel half, is all one piece. Okay, so this and then this one shaft that sticks out here, this other end, this one piece, this shaft sticks out here, and these two halves are pressed together by way of a crank pin. See it right there? And you can also see how this one slipped. All right, this is a plug. It's actually a hollow pin. I think at some point we're going to get into a tech video just talking about crankshafts, but anyway, so this is a hollow pin and this entire assembly is pressed together. All right, now the way the rest of the assembly goes together, this is supported by the bearing in the case. This is unsupported and sticking out. Okay, this is your oil pump. The oil pump is inside here, inside the cam chest. Okay, this end of the pump is the suction side, the siphon side, if you want to call it that, and it floats on the crank. And you can see there's quite a bit of play that's there. But and inside the oil pump are these tiny gear rotors. This is one set. There we go. There's actually two sets of these gear rotors, and these go inside the oil pump. Now, one thing I want to point out, let's remove the pump. You can see the flat area on the pinion shaft. These gear rotors are supported and spin with the flywheel assembly. But the pump is a second piece that is supported there, and then through these 4 holes here, this is bolted to the side of the engine case. All right, so let me kind of outline this. You have this that's completely supported and independent of the crankshaft because this is bolted to the side of the crankcase. Then you have the oil pump, which is mostly independent from the crank because it is bolted to the cam plate, and it is only supported by the cam plate and the siphon hole here that goes into the side of the case. So essentially you have these gear rotors that are based on the position of the crankshaft because that's what's turning it and that's what it's mounted to. And then you have the oil pump and the cam plate separate. Okay, now I want to stop on that for a second and make sure that everyone, let me tilt this back up here. I'm looking at most of the guys that have, guys and gals that have jumped in, and most of you are probably familiar with everything that I've talked about at this point. So let's think from this perspective again. This is the stress point about the whole cam chain versus gear drive thing and what makes this important. All right, so we have the oil pump and the cam plate supported by one thing, rigidly mounted directly to the engine case. Then we have the gear rotors that are on the inside, that are rigidly joined to the pinion shaft on the crank. That's important, remember that. What it comes down to with chain drive versus gear drive, the reason I explain all of that is because of the big term run out on the flywheel or crankshaft. Okay, that is primarily what should determine whether or not you go chain drive versus gear drive. But run out produces additional problems that a lot of people don't think about. Now, as I mentioned, I'm going to do this one more time. With this flywheel being, let's do this, being these 2 pieces and the fact that it's pressed together, there's several things that can happen under load. All right. You've heard of scissoring, which is where it can actually slip, and these 2 halves can move this way, right? And that keeps your sprocket shaft and your pinion shaft from maintaining concentricity. Okay, they don't line up with each other perfectly. Since it's 2 separate pieces and it's supported in the crank, if this moves a little bit, you can imagine the crank is, I mean, obviously that's exaggerated, but the crank would be wobbling inside the engine case. All right, so that's going to destroy your bearings, of course, and it's wobbling, moving around. So scissoring is one thing. The other thing it can actually do is squeeze in one way or another. All right, so that's another issue. And then the last is on this pinion shaft is how warped this pinion shaft is. Okay, it is possible for both of them to be warped. All right, now back in 2007, for those of you that may have owned 2007 models, that was a notorious year for cranks. HD changed their manufacturer when they flipped over to the 4 3/8 stroke crank. And there was, when it was actually during manufacturing, it was an issue being able to find center line. And a lot of the wheels were not manufactured utilizing the geometric center line. It made it very difficult to balance the cranks. Okay. But another thing that HD did back in the day was they were paying out so many warranty claims on bad cranks, even on brand new bikes, that they actually raised the tolerance. Okay, so we'll get to exactly what those tolerances are because, again, that's going to determine whether you should run chain or gear drive. But let's remember that not only are we affecting what's the word I'm looking for, the compatibility with gear drive if the crank is a little crooked, we're also creating an oiling issue. Remember, where the pump's mounted, where the plate's mounted, the gear rotor's on the inside. If you have too much run out on the crank, you're actually forcing those gear rotors inside the oil pump to oscillate slightly. Okay, and if that happens, then you can aerate the oil mix. It can create bleed down issues. It can create oil feed issues to the rods. I mean, everything. It affects everything. Remembering the cam plate is the oil distribution block. Okay, so what we have to do is ensure that the pump is in perfect alignment, that the gear rotors on the inside of that pump are in fantastic alignment, and everything's nice and straight, nothing's in a bind, and then you'll get proper oil distribution. But what you see most commonly, I'm hoping this will show up. Let's look at this side of the pump. All right, can you guys see that? See how smooth that surface is? All right, now let's turn the pump around. See the grooves down there on the bottom? And from the inner gear rotor and the outer gear rotor? All right, so you can see the difference from one side to the other. So here this pump was mounted, and we had a crank that had a few thousandths run out, wobble in that pinion shaft, and it's essentially grinding into the pump on one side, aerating the oil and rapidly progressing the wear rate of the other components inside the engine. Okay. Can I get a thumbs up on that? Everyone understands the importance of a straight crank. All right. I want to make sure we cover that first. Now, obviously, abuse, real hard, significant decel, dumping clutch on acceleration, real hard abuse and stuff like that can create some issues with the flywheels just because they can twist and spin and move. A lot of them were defective from the factory. Okay, back in the early days, when you straighten and true one of these cranks, I mean, your target was 1 to 2 thou, somewhere around there, as a specification. When you take the end of the pinion shaft and you put a dial indicator on it, you spin it around, you're looking for the amount of wobble that's there. Okay, now. And in the early days, Evos back and stuff, it was, half, 1 thou, something like that. Twin cams, 2, 3 thou, give or take. But when you got into 07 and later, there were some that you would see, even remember on brand new bikes that were in the 6, 8, 10, even 12 thousandths allowable range. Okay, allowable as a manufacturer, so they don't have to pay out warranty claims, but not proper for gear drive, nor healthy for the oil distribution system through the cam plate. Okay, so the other interesting thing about the crank and measuring runout, I'm going to throw this little tip out there. As I showed you, both sides of the flywheel are supported by the bearings. Everybody remembers that. All right, you have that sprocket shaft and that pinion shaft on both sides. All right, most of the time people will measure, I've seen it done many, many times, they will measure the runout of the pinion shaft side with the cam support plate bolted in place. Okay, I believe that the cam support plate can aid in keeping that straight to some degree. So when I measure mine, every time I put in a set of cams, I will make sure that the cam support plate is out, and I'm measuring just on the tip. But the other measurement to consider, okay, and when you're doing an upgrade, it is worth it to go ahead and pull the primary and the compensating sprocket from the left-hand side. Open that up so you can get to the sprocket shaft, right? Because what we want to do is actually measure the total runout. Remember that it's supported on both sides. So we only want to see what this side's doing. We want to see what both are doing. And if we measure both sides, we get what's called a TIR, which is total indicated runout on the entire flywheel assembly. All right, and that is truly the 100% way to know that thing's healthy, not with just a cam plate installed and just on that right-hand side. But if you have less than a certain amount, say less than 3 thou or something like that, 3 thousandths on the pinion shaft side, more than likely the sprocket shaft side is okay. But it's always good to look. Do it once and done, right? That's my philosophy. So, gear drive versus chain drive. I think everybody's on the same page with crank and everything else. I think I do. This is just one gear. Okay, you can see this is a straight cut gear assembly. And the way that this would work on the cam plate, you have the cam plate assembly here. You would have, you know, a large gear here that would make to that, a straight cut gear. One there, you would have a gear there, and then on the back side, you would have 2 gears there. So you have a direct drive all the way around on all sides. All right. Now, there is no question that there is really no substitute for 100% accurate valve timing, okay? And that's what gear drive provides you with, is 100% perfect valve timing, because everything is direct drive. All right, where the issue comes into play is the runout on the crank. And it's pretty much a general specification that you need to have. And I don't like to put gear drive on a bike that has 3/1000ths run out on that pinion shaft side. I don't like to put gear drive on one that has a total run out of 3/1000ths. But that being said, kind of the industry standard, if you will, is no more than 3/1000ths run out on the pinion shaft is kind of the determining factor. Okay, as to whether or not you can run gear drive. Now, what happens, I'm going to see if I can show you, it's pretty evident on this gear. First off, the teeth are extremely sharp. All right, now we're going to see if we can see this. All right, watch as I roll this around. You start seeing some wear marks. See the dark line that's coming up through there? And the uneven wear, you can kind of see where it's polished on one side. And then look at the difference of the teeth thickness as I roll this around. So it gets a little sharper, and then see right there, a little extra wear. So this was put on to, this gear drive was put on one that had about 6/1000ths run out, and it was whining like crazy. All right, so what happens is when you have more than that run out, you're creating that, you know, that offset, that wobble. And essentially it beats and chews the gears to death. All right, so remember, everything is direct drive, so none of the parts have anywhere to go. So if you have way too much run out, then you're essentially just stressing the pinion shaft, and everything's moving around in there, and that's not a very good thing. All right, well, that's one specification there. The other is backlash on the gears, and that one is just as important. You've probably heard some gear drives where people say that gear drive is incredibly noisy and you hear it whining. That is a surefire indicator that it has not been fit or set up properly. In most cases, you have too much backlash between the gears. Now, what that means is when you have your large gear at the top that's connected to the rear cam, and then you have this gear that's connected to the pinion shaft on the crank, there is a certain amount of backlash between the teeth. Click, 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 like that, okay? That backlash, that tolerance is 1/2 to 1/1000ths of an inch. That's a very, very tight tolerance. Fortunately, Andrews via, or S&S via Andrews, they make undersized and oversized pinion gears that you can buy. So installer that it should be standard practice to make sure that you have less than 3/1000ths run out on the crank before you install anything. And then when you assemble it, you go and check this, the backlash on that pinion gear to the cam gear, and it should be between 1/2 and 1/1000ths. Now, often, I will tell you guys, that means you have to wait a few extra days to get your bike back. Because you don't know what that measurement is going to be until you do the installation. All right, it's kind of like us when we do our engine blueprints. We put those together, and we will measure what the deck height is on the piston, because there's always a little bit of variance on cylinder height, a little bit of variance on, and then you have stack tolerances for the engine case and stuff. So we would order custom head gaskets to get the quench exactly where we want it, but you don't know till you put it together. So be patient with your shops. If they're telling you that they've put your gear drive together, they need to order this custom one, then be patient with them and let them do it, guys, because what that's going to do is ensure that the job is done right. So that's a major factor there. So the backlash in that is equally important. So I'm going to stop for a second before I divulge on opinion on this. Does anyone have any questions about anything yet on what we've discussed? I think we're pretty clear. We're in good shape? Okay. Now, let's flip to opinion. Okay, we know the facts. First, when people ask me, should I put in a gear drive? What I always say is, first off, we measure the crank and see if the crank will allow for it. Okay, that should be done regardless, because it could uncover an unknown problem. For example, and we have all too often opened engines up. A guy just wants a set of gear drive cams in it, and we find he's got 8, 10, 12 thousandths run out. Okay, which means the engine is on a fast path to self-destructing. All right, and once one is moved that much, that could actually be a catastrophic failure at that point. And catastrophic engine failures at 80 miles an hour on an interstate cannot sometimes not be a good thing. So we have to remember that. So what I tell people is we need to measure the pinion shaft first. If it's less than 3 thousandths run out, then I would say that it's suitable to put in gear drive. All right. The second thing is, does your budget allow for it? Okay, because a cam plate and oil pump, they typically range, depending on the brand that you use, they range between about $500 for a billet cam plate pump assembly, $500 to around $750 to $800 in that area for a cam plate and oil pump assembly. The gear drive adds, if you're already installing cams, the gear, changing over and doing gear drive versus chain adds about another roughly $450 to the parts to do the gears. So the answer is, should you run chain or gear, with some caveats, which I'll get to. Will the crank allow for it at a 3 thousandths run out? If that's a check mark, yes. I recommend opening up the primary side just to double check the sprocket shaft to make sure that your total run out is acceptable. Okay. And if it's within your budget, there is no question that there is an advantage to running gear drive. Okay. Mainly for peace of mind. All right, you don't have the cam chain tensioners that you have to worry about anymore. All right, and it's a direct drive setup. So in that situation, if it fits the budget and the crank will allow for it, there is no downside to running a gear drive. And then again, there is no substitution for absolute perfect cam time. But the big question is, do I have to do it? Is it a have to? Must you put in gear drive? And the answer to that question is no, you don't. You don't absolutely have to. We have built some absolute monsters, believe it or not, and have had very good luck with the cam chain, the stock cam chain setup. But you want to do your due diligence, right? Is there a gamble with a stock cam plate? Absolutely. There's a gamble with any cam plate. I have used every manufacturer's cam plates out there, and at any given time, I have had a problem with at least one of them. So there is always a gamble that you could have an issue with a cam plate. So as far as switching to gear drive, the reason I keep referring back to cam plates is because let's discuss the other options. Okay, so let's say, for example, a person has it in their budget to go, say they've got a 99 to 06 model and their cam chain tensioners are wore out, and you check their crank, and let's say they only have, they have 4 or 5 thousandths run out on the pinion shaft. Okay, but it's not in their budget to rebuild and straighten and true a crankshaft or flywheel assembly. It's just not in the budget, but they have to do something in the cam chest. There's several options that you can that are workable. Okay, the first thing is simply to take the stock chain and get on a polishing wheel with some jeweler's rouge and a sander and polish the edges of this chain. All right, now you'll see the edges of the chain, there's absolutely no casting marks on this one, and you'll see it's got a nice polish to it. All right, we've polished this one. All right, so get that really good smooth surface there will help in reducing the amount of wear on the tensioner. And then as the most budget fix, you put a new tensioner on it, you make sure that this chain isn't stretched, you make sure there's not too much play in the links, okay? And then do a finite measurement on the chain on the one coming out versus a brand new one to make sure that the chain isn't stretched too far. Now, if it's stretched too far, the valve timing jumps all over the place. So just make sure it's not stretched too far. Make sure the links are in good shape. Roll like this. Make sure there's no links that are are stiff or anything like that. Polish those edges, and you can get that guy back out on the road without breaking the bank. And again, this is an option if his budget is really tight. Okay, that's one way to go. The other, again, if you have more than 3 thousandths run out on the flywheel, but we want to make some kind of upgrade. The other option is to put in a conversion cam plate. All right, so there are early cam plates that are available that will bolt into a 99 to 06, but utilize the hydraulic tensioner from the later models. Okay, so that's an excellent upgrade. And how you would really know the difference, the cam journals would be the size of the early ones. But if you notice this flat area on this one and see the little oil feed hole there, this is a hydraulic cam plate. And you can see here a little oil feed hole that's right there for that one. And I probably have, let's see, I've got a couple of cam plates back there. I'm dig them off the wall. The other cam plates that you would see a post if it were, for the spring loaded, you'd see a post there and it'd have the spring loaded tensioner on it there. But you can convert, that early style 99 to 06 to a hydraulic cam plate. Those, depending on where you get them, can range anywhere from between about $500 to $750. And then what happens with those conversion plates from one particular manufacturer is it will retain the original style chain on the back, but on the front, between the cam and the pinion shaft on the crank, it converts it to this bicycle style chain or roller chain like this, and then uses that hydraulic tensioner on both sides. And so that's a good option as a way to upgrade. They get a better cam plate, a billet cam plate, they get a new oil pump, and you're still improving on that stock spring-loaded tensioner design, and it should last them a lot longer. So I would say if you really have 3 different options there. You check the crank. If it is if it's within 3 thousandths run out, and the plate itself isn't worn where the pinion shaft goes in here, and it's not worn too bad, to where you can get an oversized gear on there to if you need to measure that backlash and get exactly where it needs to be, then your apps, if it's in your budget, absolutely do gear drive, no question. It's no question. It's a great, fantastic upgrade. If it's above 3 thousandths, it's not in your budget to do to replace the crank. Then your options are, if we're on a really tight budget, your options are to polish the chain, put stock spring-loaded tensioners back on it, and go down the road and know that you probably should check it in about 30,000 miles or so. Option 3, if it's out of spec, would be to convert it from the original spring style to the hydraulic tensioner system, converting it with the chain and that sort of thing. But again, if you have a flywheel that's more than 6-8 thousandths run out or something like that, we've got to keep in mind that there are other issues that can be created, and again, creating catastrophic engine failure type stuff. And when that happens, that it can get exceptionally costly above and beyond just splitting cases and replacing flywheels.